Hello, everyone. Welcome to our webinar, Risk Analysis of Mega Projects. Just a quick introduction. My name is Michael Trumper. I'm one of the principals here at Intabor Institute, and I've been working area of project risk management and software development for over 20 years. Before we get started, I'd just like to go over a little bit of housekeeping, we call it, just to show you how you can interact with it during the webinar. So this first time pane that opens up in the top right-hand corner, I always recommend using the mic and speakers if you have them, rather than telephone, as the quality will be better. If you have questions, you can ask them in the question pane. We'll, with the condition that we're not going to answer them right away unless they're actually a technical question, like you can't hear me, or there's something else going on technically that we might want to be looking at. Other than that, we'll have a Q&A after the fact and look at any questions and answer them in the order that they came in. So with that put away, we can move on to the meat of the webinar. So just to start off with, what we're going to do during the webinar, I've got a few slides, and it's based on the a presentation we gave several months ago at a conference that was looking at project and schedule risk analysis. And oddly, this seemed to be a fairly common topic. I think there's 2 or 3 other presentations that were given at the conference on this exact or same topic. However, obviously some of the methods and processes that we used were slightly different. So I'll go over that, and really what we're going to look at is we'll look at a few slides just to discuss what it is, and we're going to be looking at a couple features that we have introduced into RiskyProject over the last couple of years that we think can help with the management and assessment of these very large projects or project portfolios that we are seeing that are becoming more popular, let's say, within various industries. So by definition, projects are very large and complex and are extremely challenging to manage. And running on these schedules adds even more complexity and management challenges. So in when we talk about mega projects, these large, extremely large, complex projects, the one that we're going to use for execution and day-to-day management doesn't actually have to be the same one that we use for the risk analysis. It's possible to use a simplified project schedule, a project plan, to be able to produce valid risk analysis. But the question is, should we simplify them? Because there are pros and cons for both, on both sides of it. One, pros is that they're easier to maintain, with some codicils on that. And that's probably, it might be the easiest, the single biggest benefit from that. The next thing is it filters out the white noise. When I talk about white noise, it's when we have these massive schedules and we run an analysis on them. One of the things that we do like to look at is sensitivity analysis. happen when we have these very big schedules. There are so many results that come out. It becomes very difficult to actually, you'll have, you could literally have thousands and thousands of activities that have the same sensitivity rating. So it becomes very difficult to understand what are the main drivers in your assessment and where you're going to put your management efforts in when you have these extremely big schedules, especially if you're just using 3-point estimates. If you're using risk drivers, a lot of times it becomes a bit more clear about which risks are going to be have the most impact on your project schedules. And finally, simulation performance, especially if you're doing multiple runs, you're doing some, let's say, branching, or you're doing scenario analysis. When you have these extremely large schedules, even with the most up-to-date software and the most powerful computers, if you have tens of thousands of activities, the time to run a valid analysis can be can take quite a long time. So simplifying it will bring down the time it takes to actually run those simulations. Now, what's on the con side? Well, they can be difficult to create. It's not just that we can create one, it's very difficult to create a valid one, because it can be hard to actually estimate, or easy to underestimate how long it's going to take you to create one of these simplified models. Because not only do we have to move, we're going to remove activities, but you have to do it in such a way that the logic, the central logic of that schedule needs to be maintained. If you remove a lot of activities, merely by doing that, if we simplify, it's possible that you're going to get overly optimistic results from that, because a lot of the risk in project execution that you get is from the execution of these activities in the order that they're scheduled. And by removing that, it's possible that you're going to get overly optimistic results. And finally, it could be redundant. If you've taken the time to actually build schedules that have solid logic and are updatable, which is a key part of running schedule risk analysis, in that if we make changes that it updates properly, that you're just creating extra work. And if you're running analysis during project execution, then you have two different models that need to be updated and make sure, check for and whatnot. So it does make sense. It's one of these balancing things, which is you do, and you need to take into account both of those things. So in Tabor Institute, we've been working with this for quite a long time. We've come up with two solutions. One is schedule consolidation, and one is subprojects with risks and uncertainties. Now, these are actually two features that are built into the software that actually do automate at some point some of the work that you might do if you're looking to create a more manageable schedule project plans for running the analysis that still remain valid. So what we want to be able to do that is the ability to perform that risk analysis on projects of any size and on a regular basis. So what does schedule consolidation do? It's basically a way to simplify the project schedule. Consolidated project schedule is the equivalent or has conformity with the original project schedule based on the main project parameters: finish times, milestones, duration, costs, resources, etc. All of the things, the data points that we can have in there. Schedule consolidation can significantly reduce the number of tasks by removing sequential activities and replacing them with larger consolidated activities. When it does this, the risks and uncertainties are applied to consolidated activities, which simplifies the interpretation of the results of the analysis. So that's the first thing that we've run in. And so we have an algorithm that will run this against large project schedules. And so this is just an example that we might have, a very small one, and we'll show this in the software as well. And one of the things that haven't taken into account, you can actually do multiple runs of this, and it will actually, once you've done one run, the algorithm stops after the first one, but you can run it again, and it will actually shrink it a little bit more as it finds other activities that can be consolidated. So we've been able to, in this one, it's about a 30% reduction in the schedule. And if you, in the past, we had one project schedule that had over 80,000 activities, and we were able to reduce that down on the first pass down to 50,000. We didn't go any farther after that, but I imagine just based on some of the testing that we've done since then, that we could further reduce that down into a much more manageable size in terms of being able to run, because at 50,000 or 80,000, you're still taking quite a bit of time and horsepower on your computer to be able to run those. So a master model with subproject. This is another one that we, another feature that we developed that's somewhat based on what I would call master projects in Microsoft Project or some other scheduling engines. And the basis of this is, or the mathematical foundation for it, of analysis was developed, is an extension of the finite element structural analysis that's used in engineering, and it's called static condensation. So if we look at most structures that we build, such as bridges or buildings or other engineering objects, such as launch vehicles, they consist of many similar smaller elements. Structural analysis of each element is performed individually. Then such elements that are common across them are inserted into a main structure's finite element model. As a result, a much smaller model needs to be analyzed to get a valid assessment of the structure. And so we can apply that same sort of mathematical foundation to our project schedules, because project schedules also consist of many similar elements. These can be subprojects with again repeated elements. And Monte Carlo, what we can do is we can run the analysis on the very smaller projects, save the simulations to the project, and then insert them in a larger portfolio or program of projects and run a valid risk analysis on the overall master project, or you want to call it portfolio of projects. So here's an example of a project with subprojects. If we're just looking at this, and I'll show it in the quick demo that we're going to do fairly shortly. In a large program or portfolio, the Monte Carlo analysis of project schedules can be performed individually to generate a risk profile. These profiles are a custom distribution of costs and schedule that can be inserted into a master schedule as one task or a small group of tasks. Risk analysis of the master schedule is run based on the risk profile of each subproject. So in this little example, in the demo, we have 5 tasks, but 3 of these tasks are actually subprojects, which have many tasks in themselves, but are calculated separately. In this way, we can actually run the analysis on the smaller projects, get the analysis, do our assessment on probabilities, margins, and all those sorts of sensitivity analysis. But we can actually then insert them into a larger project and get some assessment of the overall probabilities of meeting certain deadlines, milestones, etc. So with that, I'm going to quickly move over to our and show a quick demonstration of the software. We'll start off with a small project schedule here. Just to let, if you haven't looked at our software, this is RiskyProject 7. We just, if we want to just check, this is 7.1. And I created a very simple project schedule here for an example of how this works. The consolidation feature is put in the tools here. I'm not exactly sure why, but maybe for spaces, but we put it in here. And to run the consolidation, all we do is have to click on this. This is going to happen almost instantly because of how small this schedule is. But on a larger schedule, larger project schedule, it can take a little while to run through this algorithm. But to run that on this pre-consolidation, brings up this. And part of this is actually we're going to be running it on a deterministic schedule. So we haven't, one of the limitations of this, we can't put the uncertainties or on the schedule prior to running the consolidation. And what we see here is that we've run that schedule consolidation, and this one, because it had a lot of sort of repeated activities, we've seen that we've gone from 15 number of tasks before to a number of tasks after consolidation, which is 6. So this will, on a very, very large schedule, this one again, very simplified, so we probably wouldn't get those sort of results. And we managed to bring it down by one more there. So you can actually run that through a few more times. But what we were able to do on very large project schedules, to take a little bit of, and this is not AI or anything or machine learning at all in this. This is really just analytics that goes through, looks at your project schedule, looks for activities that have a single point or group of activities that have a single point of entry and a single point of exit in terms of their linkage. And we can actually bring those together and consolidate them into, and one of the things we can see is we have risks on here as well, and these risks are being assigned to all of the tasks that were within those originally. One of the things that it does is it actually does a little bit of a modification, taking into account the ranges. If the risk impacts and whatnot or differently, it will prorate them based on the original risk assessment. That's the first thing that we can do on this. The second one that we brought in to help dealing with project risk is, I'm just going to give us some idea about what we're. So this is a sub-project that we have. It's actually one of the sample files that we have within the system. One of the things that we have to do, you can see I've just called it Subproject 1. In this master project, I believe I put in 3. Calculate this up. And one of the new features in 7.1 that was put in is that it will save, it actually saves the results for the current schedule. Whichever baseline if you're having multiple baselines now, but it has a standard. If you haven't saved a baseline, the results are going to be saved with the file, so not, which is a new feature that we also added to the software as part of scenario analysis. So we do have the results saved. Now, and what we've done, what we do is I'm going to just open up this master project schedule. And what I've done is I have 3 projects that create part of this project portfolio. Now, they don't have to be just sub-projects. We can actually put in other activities within them. But for simplicity's sake, I just decided I put these 3 sub-projects in. And one of the things that we can look at is for each sub-project, we look at the distributions. It comes across as a custom distribution. So we have the custom distribution for cost. Oh, we don't have any cost on that one, but it will generate it for cost and duration, and it put that in there. So this is the results of that analysis of the first of this sub-project. You can see on this one, it looks like it has a lot of risk events. So we're saying these various peaks in here being caused by risk events occurring. On the same, let's see it here. Yes, in this one we do have cost. Again, very typical. Duration, we're seeing the same sort of raw costs and with these sort of distributions that you get with risk events, where this looks like to be the normal. If we look at that, that is probably the deterministic schedule with some uncertainty, risk uncertainties. Then we have some risk events that are driving the costs there. So what we've done on that is we've actually included this. They do have, one of the things, they do have some hard start times in here, just as part of as we put them in. But we can calculate that. We look at the project analysis. This analysis that we're getting here is a risk assessment of the entire portfolio. And if we want to pull out any of the data that we can do here, we can see all of that here. So what this allows us to do is to run analysis on each one of these sub-projects, be able to pull out detailed analysis of this sub-project, which will help us, especially on things like sensitivity analysis. Especially on things like sensitivity analysis. Let me see what well, there's no risks on there. This does allow us then to do some detailed analysis at a very micro, if you want to call it a micro level, at the project level, but also bring that up. And once we get to the portfolio level, we get to see those very high results. And at this point, we're because one of the problems that we did mention earlier is that you have a problem with with the massive amounts of results. So it doesn't really, we're not going to be looking so much at sensitivity analysis. This will probably, most of the analysis that we're going to be looking at the portfolio level is really about how likely it is that we are to meet certain dates, certain milestones, and overall delivery dates, probable or confidence level and delivery dates for cost and schedule for the program as a whole. With that, I think we've just about tried to keep these under about half an hour. We're right at there. If there's any questions that anyone has. I'd be happy to answer them right now. Looks like we don't have any questions. So if you do have any questions, you can always get back to us. and at www.tabor.com, and we'd love to hear from you. This webinar is going to be recorded and up on our site if you want to get a recording of it. We'll have it up on our site probably within the next 72 hours, all depending on how quickly they send us a recording from our GoToWebinar. But we'll have that up and for your review. Well, thank you very much, everyone, for your time and patience. And have a good day and keep safe.